I am obliged to organizing committee for giving me this opportunity to discuss my work. So I am Sunanda, a PhD scholar at Indian Institute of Technology, Jodhpur, working under supervision of Dr. Ritanjali Morana. So here I will discuss about the modeling of TXS blazar. This blazar, I think you have some idea about this blazar because we have two lecture. What is the blazar, right? So I am going to discuss about the modeling of the blazar TXS0506+056. So this blazar itself is very important because it has ice cube neutrino correlation. It has spatial and temporal correlation with the ice cube neutrino event. So which was observed this ice cube neutrino. Okay. Okay, so this blazar has a spatial and temporal correlation with this ice cube neutrino event, which was got observed on the 22 September 2017. So after this observation, all the detector in the globe has started to observe multi-wavelength observation for this ice cube neutrino event. Okay, so here you can see this event got observed. Okay, I'm sorry. This event got observed in optical, in VLA, in optical, and also in the Swift X-ray, and its event also have this Fermi. I have a difficulty in this, so could I like?
You can also use, yeah, you can also use this pointer here.
Or this fine, like.
Yeah, or you can back and forth, or you use the, yeah, this is also good.
Okay. So here you can see this event also have Fermi flare association, and it is also got observed by very high energy in very high energy photon. And now let us look in the temporal correlation of this event. Here you can see this is the this ice cube neutrino event is falling in this this Fermi flare episode, and however MAGIC observed a very high energy event after the several days of this ice cube from the peak of this flare. So however many detector also started to observe for this high energy, but no detector like Veritas has claimed any high energy photon during this time period. So we can conclude here there is a time difference between the high energy photon and very high energy photon which got observed by the MAGIC. So let us see what is the implication of this time difference. So here I have listed the epoch through which this multi-wavelength observation of the TXS0506+056 laser got observed. So here I want to emphasize again there is a time difference between the event which was got observed. There is a time difference between the event which was got observed by the Fermi and also a MAGIC telescope. So so here I myself has done this light curve analysis of this Fermi Fermi data, and here you can see there is a separation between this time period after the 25 September, and MAGIC observed very high energy photon during this time period 28 to 4 October. So there is a time difference, and here I analysis this Fermi data, this event for 3 energy beam, this 0.1 to 100 GeV, then 100 to 800 MeV, and then 800 to 1 GeV. So and I also want to emphasize this light cube analysis is for ROI 12 degrees for 12 degree and with the energy pins of 3 days. So here you can also see there is a time difference between these two observations. For this modeling of the source, we have we propose how to explain this time difference between high energy event and very high energy event, which are observed by the magic. So to explain this time difference, we have used we are proposing two model here. One is the synchrotron and second is the proton synchrotron. So here I am presenting, this is the fitting, this is the first synchrotron and this is the SSC contribution. Here I fitted this very high energy data observed by the magic with the proton synchrotron. So here you can see this electron synchrotron and proton synchrotron can explain could explain this time difference very well. So, and for this modeling part, I have used this camera package, which is the time dependent package available for Asian for modeling. So for this calculation of the time, as this modeling require 3 gauss of magnetic field, we calculated the time difference. We calculated the proton synchrotron time for 3 gauss magnetic field and found it is explaining the magic data observed by very high energy gamma photon observed by the magic. So here I am representing this cooling time. Here you can see this blue dotted line is the electron synchrotron and this orange line dotted line, this is for proton synchrotron, and this is the time period. Actually this is the time period in the observer frame. So here you can see we could explain, we propose here this time difference between the high energy and very high energy event could be explained by this two production channel because of the fact that there is a time difference between the electron synchrotron and the proton synchrotron. So to summarize all these things, so as this multi-wavelength study of this TXS blazar suggests there is a time difference between the high energy event observed by the Fermi and the very high energy event which were observed by the magic. So to explain this time difference, we propose here two production channel. One is the electron synchrotron. As I mentioned, for fitting the initial part, I have used electron synchrotron, and up to Fermi data, I have used SSC. And for very high energy photon, which got observed by the magic, I have used proton synchrotron. So, and we calculated for this modeling purpose, we have used single zone model, and in this single zone model, what we observe, what we consider injection of the particle. In the initial state, we have assumed there is an electron and proton inside the blob, and then there is an emission, and then for this evolution, as you study, as mentioned in the last lecture, this electron and proton follow the power law, right? And according to that, using this camera package, we have model for the source, and as I mentioned, this modeling part require a magnetic field of 3 gauss, and for that magnetic field, we have calculated the time period for the proton synchrotron and also for electron synchrotron, and found we could explain this time difference between the high energy and very high energy by using this two production channel. And for this modeling, we have calculated the proton luminosity, that is 10⁻47 erg per second, that is consistent with the Eddington limit. At the end, I would like to mention this apparent delay, which I discuss here, could be due to the non-optical weather condition in which MAGIC observed very high energy photon on 24 September. So but however, no this bad condition was reported by very other detector like Veritas and HAS did not reported this bad condition at their site. So here we are giving just possibility how we can explain this 2 decay using this electron synchrotron and the proton synchrotron. Thank you. Well.
Other questions? Yeah.
Hi, thank you for the talk. This might be a stupid question or I might have missed it, but if the events are different energies and with the time delay, how do you know they're both from the blazar, the same source?
Different energy, and so you are seeing could you please repeat your question? Like
so how do you know they're from the same source?
These are coming from this actually. Okay. Because this source itself is very important because of the neutrino event, and to explain neutrino event there are many model has been studied, and in that case they have used this P gamma interaction and PP interaction to explain this neutrino event. So when we do this modeling part, we need to keep this blob neutralized. So in this case, we consider electron and proton, and for this electron, this to explain this MAGIC data, we decide the energy range, and also to explain. Yes, here we did not include that neutrino part that has been explained in one paper, that is by I think Go paper, in which they have considered 2-zone model. So here we emphasize how we can explain there is a time difference between the high energy and this very high energy event. And this very high energy event, actually, when this event, ice cube event was observed, then same multi-wavelength observation was taken by the different detector, and it was within the 1.1 degree area. So I think this is the by which they confirm they are coming from this TXS source. So these are the observations which are taken by the MAGIC in the high energy, and these are the observation. So and ice cube confirmed that these are coming from confirm that these are correlated with this TXS source.
Great, thank you.
Okay, thank you. I think we have to move on. So let's thank Sunanda again.
Thank you.